Hey you guys, this is the 3.4 fundamental theorem of algebra lesson, but we're just going to do the first part. So if you look down here, we're going to stop at the end of this page and then we'll do this part later on. But for now, let's go through this. So the fundamental theorem of algebra says that if the function f of x is a polynomial of degree n and n's bigger than 0, then f has at least one zero in the complex number system. And I was looking online, and I don't know that this part is necessarily true. I'll dig into that a little bit deeper, but what remains is the fact that we talked about the number of this exponent is the number of solutions or zeros the function's going to have. So in this case, because it's a power of 2, that means there will be two solutions. Now, there's also a pretty significant typo here that I want to make sure we all catch. Can you please change this to a plus? So I want to change this to x squared plus 64. And you'll see why once we do the solving of this. So what we're supposed to do is find all the zeros of the function. And basically all that means is we want to know when is the function equal to 0. So what we're going to do is take this and change it to 0, and then we'll solve. So when we do this, we don't have to do any crazy factoring or anything like that. We can just drop our line and solve. So we would go minus 64 minus 64, and we would get x squared equals negative 64. Then the opposite of squared is square root. So we would square root this side and square root this side. Hopefully there's a little bit of a red flag going off because we're trying to square root a negative. If you type that into your calculator, it'll say non-real answer. So what that means, if it's not real, it means it's imaginary. So the regular square root of 64 is 8. But when you have a negative, it becomes 8i because it's imaginary. It's not real. And then just remember that we have plus or minus 8i. So we have 8i and negative 8i. So those are the zeros. And then part B says to write the polynomial as a product of linear factors. So a product means multiply. So we want it to be a multiplication of linear factors. This means it's x to the power of 1. So we can't have x squared or anything more than power of 1. So what we're going to do is we're going to take this and write out what factor it came from. So that one came from x minus 8i. Then we're going to take this one and write the factor that came from. And again, we're writing it as a product. So we're writing them being multiplied together. So this one would have come from x plus 8i. Now, just to be super, super clear, if we took and made a little box of those two things, if we went x 8i, x negative 8i, and you hammered out these four boxes and added them up, we would get right back here where we started. Okay, so we're basically just breaking it into smaller pieces. So if it asks for the zeros, it's looking for these. If it asks for the polynomial as a product of factors, you would write it like this. Okay, now the reason I wanted to switch it to plus is I wanted to show you that if we have one imaginary solution, we're going to have two. They always come in a pair. Imaginary solutions come from square root of negative, like whatever that is. And you're going to come out with plus or minus times I. So you're going to have two imaginary solutions. All right. So in these ones, it says find the polynomial function f of x. Uh-oh. There we go. With real coefficients that has the given zeros. What that means is they gave us these zeros right here, and we need to make the equation. So they gave us 4 zeros, which means our final function will have a power of what? What will the highest power be? It's going to be x to the 4th, something here, and then there's going to be other stuff here. But we know the highest power is going to be x to the 4th because there are 4 zeros. So what we would do is start by writing our factors. So the first one, when x is 0, sorry you guys, anytime I touch it, it's changing. Okay, when x is 0, that means that factor was just straight x. When we have 5, that came from x minus 5. And then if we have I, that came from x minus I. And our last one would have come from x plus I. So now all we have to do is multiply these. And we've talked about this. There's a difference between hard and tedious. It's a little tedious, but it's not hard. So we're going to take, and this one we can just go pew pew like that. And we get x squared minus 5x. And we'll just hold that there for a second. These two we can put into a box. And then knock those ones out. So we have x squared minus xi plus xi, and then negative I squared. Throwback, I squared is the same as negative 1. So this is really just 1. These two cancel out. And then we're left with x squared minus 1. Big thing to remember here is we're multiplying all this garbage. So now we've done one box. We just need to do one more. And we'll be good. So we're going to put x squared minus 1 there. And we'll do x squared minus 5x there. So we get x to the 4th. Oh, that's good. Remember at the start we said it's got to be x to the 4th, so that's looking good. And then we've got negative 5x cubed, negative x squared, positive 5x. And then if you just write these all out, you get x to the 4th minus 5x cubed minus x squared plus 5x. Nothing can really be combined, so this would be, whoopsie, what was that? This would be our, holy Hannah. Okay, that would be our final solution. That would be the polynomial function with real coefficients, and it has those zeros. Okay, so we have one more. What I'd like you guys to do is, I'm going to have you do part of this by yourself, but I'll tell you when to pause the video to start. So remember I mentioned that we always have 2 imaginaries. Well, right here we only have 1 imaginary, so we are currently missing the negative version, so we need negative 3i as well. So if you ever see a single imaginary term, add a second one because it should have a positive and a negative. So now what I want you to do is pause the video and write the factors. So the factors are, I'm going to try to, that's this step. What I want you to do is write this step for that problem. Okay. So now, if you have hopefully unpaused your video, we would have x minus 4, x minus 3i, and then x plus 3i. The second step here was that we needed to multiply all the stuff. That's what we did in this area right here. We multiplied the pieces. I'm going to just give you a quick tip. If you have the positive and negative version of the imaginary, do those first because a bunch of stuff is going to cancel off. It's going to make life a lot easier. So pause the video and make a box to fill in of the two imaginary terms. So pause that and fill in the box. All right, so I'm going to go 3i here and minus 3i here. You might have arranged them a little bit differently, but you'll end up with the same thing. So here we would get x squared. Here we would get 3xi. Here we'd get negative 3xi. And then here we get negative 9i squared again. That's like negative 1, which is like 9. So these drop, and what we're left with is x squared plus 9. You might start to notice a pattern after a little bit. And, oh shoot, which just made me realize, crap, on this last one, I just noticed this should be a plus 1 right here, which makes this a plus 1. Which makes this plus and this minus. Okay, which makes this plus and this minus. I'm sorry, you guys. This part right here, I copied it wrong. So when I wrote it up, I copied this part wrong up there. I apologize. But what you'll notice is whatever you're trying to like find the positive and negative of, it's going to become like 3 times 3 is 9 positive. 1 times 1 is 1 positive. If you don't understand what I just said, ignore me. Okay, and then we still need to do our last multiplication, which is to take this guy times this. So pause the video one more time, make one more box, and multiply out your last box. Okay, when you multiply them, you get x to the third, negative 4x squared, 9x, and negative 36. None of those can be combined, and we end up with x cubed minus 4x squared plus 9x minus 36. And then we have power of 3, which is great because in the start we had 3 roots. Okay, cool. I will finish up with you in the next class, and if you have any questions, just make a note on there, and hopefully I didn't screw you up too much with my little sign issue.